The current in a circuit depends on the voltage and the resistance. And those three items, the current, the voltage, and the resistance, are related through what's called Ohm's law, which just is V equals I times R. Voltage equals current times resistance. If it helps, you can think of all this stuff in terms of an analogy with a river. The current in the river is kind of like the current through a wire. It's just the flow of water versus the flow of charge. If you think of like a river as being like pretty much mostly level, there's not going to be much current in the river because there's not really much of a difference in gravitational potential energy. Remember, that depends on the height. But if the river is kind of like sloped downward like this, there is a difference in gravitational potential energy between the highest point and the lowest point, and that difference in potential energy will give you more current. In the same way, it's like, think of the gravitational potential energy as kind of like the potential of a battery or the voltage of a battery. The more voltage there is, the more current there's going to be in a wire. And then you've got the resistance, which is kind of like the things that kind of go against the current. So, like if the banks of the river get kind of narrow and come together, or if there's like a lot of rocks and things in the river, that's all going to give resistance to the water current. And in the same way, the current in a wire, the electron flow is hindered because there's like interactions with the atoms in the wire. Example 15.3. Got a small flashlight bulb that draws 300 milliamps of current from its 1.5 volt battery. And it first wants you to draw a circuit diagram for this situation. We haven't talked about how to draw a circuit diagram, so I've just done a bunch of these in the examples, so this is how we're going to introduce the ideas. So the first thing you have to know how to draw in a circuit diagram is a battery. And a battery is represented by a long line and a short line that are parallel to each other. The long line is the positive side of the battery, the short line is the negative side of the battery, and there's a wire that comes out of the positive side and a wire that comes out of the negative side, and then you could just label the value of the battery, which is 1.5 volts. That battery is connected to a flashlight bulb. The normal way that bulbs are represented are kind of like a circle with an X. So it comes out of the positive terminal of the battery. This is the wire going to this bulb, and then from the other side of the bulb goes back to the battery. And there you have your closed loop, or your complete circuit. Another way that it could be drawn is this could still be exactly the same over here, the 1.5 volt battery with the plus and the minus, but a bulb just basically contains a resistor, and a resistor is represented by like this zigzagging line. So either one of those is acceptable. And then it says it's 300 milliamps of current. Current flows out of the positive terminal. So on your diagram, if you want, you can label the current as just like a little arrow saying that I equals 300 milliamps. Part B, what is the resistance of the bulb? So the bulb we can label, if you want, with an R, or the resistor with an R. And from Ohm's law, we can just rearrange that. So R would be equal to, just take this equation and divide both sides by I. So R is equal to V over I. The voltage was 1.5. The current, which is 300 milliamps, you've got to convert that into standard units of just amps. 300 milliamps is just 0.3 amps. So 1.5 divided by 0.3 is equal to 5, and resistance is measured in ohms. So that's all it is for part B, 5 ohms. For part C, if the battery becomes weak and the voltage drops to 1.2 volts, how would the current change? So we're going to use Ohm's law again, but this time rearrange it for I. So I is equal to V over R. The new voltage is 1.2. The resistance never changes, though. Once you've established a resistance of something, that's going to stay the resistance. So we said the resistance is 5. 1.2 divided by 5 is equal to 0.24, and current's measured in amps. This is the equivalent of saying 240 milliamps. So either one of these would be correct. And then part D, what is this decrease in current due to the flashlight bulb? Less current to a bulb will just make it go dimmer. It's a pretty obvious answer. Example 15.4. Suppose you want to connect your stereo to remote speakers. If each wire must be 20 meters long, what diameter copper wire should you use to keep the resistance less than 0.1 ohms per wire? So this is the basic thing of how resistance is even created using the equation we went over on the previous page, which was that R is equal to rho L over A. We know the resistance. It said it wants that to be 0.1. The resistivity, well, this says it's a copper wire, and the resistivity of copper was actually given on the previous page. It's 1.68 times 10 to the negative 8. The L is the length of the wire, which is 20 meters. And you want to figure out the diameter, so you can get the radius, and from that you can figure out the diameter. So let's rearrange this equation to get the A by itself. So A is equal to rho L over R, which is 1.68 times 10 to the negative 8 times 20 divided by 0.1, which gives you an answer of, for the area, 3.36 times 10 to the negative 6 meters squared. Area is equal to, this is still under part A, pi r squared, so we can rearrange this for r, divide both sides by pi, and square rootify it. So r is equal to the square root of a over pi. When you plug in the area that you just got, divided by pi, and take the square root, you get a radius of 0.001 meters, which is 1 millimeter. But be careful with this one because it didn't ask for the radius, it asked for the diameter, so you would have to just double that. The diameter is 2 millimeters. For part B, if the current of each speaker is 4 amps, what's the voltage drop across each wire? Well, from Ohm's law, V equals IR. The current was given right there as 4 amps times the resistance, which was given back originally, and it said that was 0.1, so it's just going to be 4 times 0.1, which is 0.4 volts. And then part C, what is the voltage drop due to the sound level of the speakers? Well, since you're slightly reducing the voltage that reaches the speakers, that just simply means you're going to reduce the sound level. In kind of a similar way that in the last problem, less current to the light bulb means that the bulb went a little bit dimmer, less voltage to the speakers means the sound level is going to be reduced.